Can human life exist on planet Mercury? When humanity gazes up at the night sky, one of the most fascinating questions that has echoed across centuries is whether we can ever expand beyond our home planet, Earth, and live elsewhere in the cosmos. Among the dazzling array of planets that orbit our sun, Mercury holds a special place as the closest planet to the sun and the smallest member of our solar system. Its proximity to the blazing star, its extreme environment, and its enigmatic history have made it a planet of curiosity, wonder, and scientific investigation. But one of the most pressing and thought-provoking inquiries is this: can human life exist on planet Mercury? This question is not only scientific but philosophical, stretching the boundaries of what we know about human adaptability, space exploration, and the limits of technology. In order to properly address this inquiry, one must look into Mercury's physical characteristics, its hostile environment, the challenges it presents to life as we know it, and the futuristic possibilities that might allow humans to colonize such a world. While the short answer may seem like a resounding no because of the brutal conditions on Mercury, the long answer requires a careful and layered exploration of science, imagination, and innovation. Mercury is the innermost planet of our solar system, orbiting just 57.9 million kilometers, about 36 million miles, from the Sun. Its small size, it is slightly larger than Earth's moon, belies its complexity and danger. Unlike Earth, which is protected by a thick atmosphere and a magnetic field that shields life from harmful solar radiation, Mercury has only a thin exosphere made up of oxygen, sodium, hydrogen, helium, and potassium. This exosphere is so sparse that it cannot support weather, breathing, or any protective functions that humans depend on for survival. One of Mercury's most striking features is its temperature variation. During the daytime, when the sun beats down directly onto the surface, Mercury's temperatures soar up to nearly 430 degrees Celsius, 800 degrees Fahrenheit. At night, without an atmosphere to retain heat, temperatures plummet to minus 180 degrees Celsius, minus 290 degrees Fahrenheit. This range of nearly 610 degrees Celsius, 1,100 degrees Fahrenheit, is one of the most dramatic temperature swings found on any planetary body in the solar system. Such extremes make the surface environment immensely hostile to human life. Mercury also rotates very slowly. A single day on Mercury, sunrise to sunrise, lasts about 176 Earth days. This means that one side of Mercury is exposed to relentless sunlight for months, while the other side remains in frigid darkness for equally long periods. For humans, this would mean living in conditions of unending day or endless night depending on one's location. Both situations would be perilous to survival without advanced technological solutions. The lack of a substantial atmosphere on Mercury is perhaps the greatest obstacle to human colonization. On Earth, the atmosphere not only provides oxygen for breathing but also acts as a shield from cosmic radiation, micrometeorites, and harmful ultraviolet rays from the sun. Without such a shield, any human exposed on Mercury's surface would be bombarded by solar radiation to lethal levels. Protective suits and shelters would be mandatory, but even these would need to be extraordinarily advanced compared to what we use in space missions today. Additionally, the absence of an atmosphere means that Mercury has no weather, no winds, and no clouds. While this might sound like an advantage, it removes a crucial cycle that regulates temperature and supports ecosystems on Earth. On Mercury, nothing moderates the searing heat or the bitter cold. This leaves the planet barren, sterile, and resistant to the basic processes that life requires. Despite its harshness, Mercury has surprised scientists in recent decades with the discovery of water ice at its poles. Permanently shadowed craters near the north and south poles are shielded from the sun's direct rays, allowing water ice to remain stable in these regions. For human colonization, this discovery is a small glimmer of hope. Water is one of the most critical resources for sustaining life, not only for drinking but also for generating oxygen and hydrogen fuel through electrolysis. The presence of ice suggests that if humans were ever to build colonies on Mercury, the poles would be the most strategic locations. Such colonies could harvest water ice and use it for survival and energy production. However, Even these polar regions face challenges. While temperatures remain lower than the equatorial zones, they are still cold, and the lack of atmosphere means radiation exposure remains a significant hazard. Another factor that affects human survival is Mercury's gravity. Mercury has about 38% of Earth's gravity, similar to Mars. This means that a human who weighs 100 kilograms on Earth would weigh only 38 kilograms on Mercury. Lower gravity could make physical movement easier, but it comes with long-term health risks. Studies on astronauts in microgravity environments have shown muscle atrophy, bone loss, and cardiovascular strain. If humans were to live on Mercury for extended periods, they would likely face similar physiological challenges. Artificial gravity or rigorous exercise regimens might be necessary to counteract these effects, though the solutions are far from perfected even for future Mars missions. Although the natural environment of Mercury is highly unsuitable for human life, technology opens doors to speculation. In theory, if humanity were to establish a base on Mercury, it would require extremely advanced protective structures. Colonies would likely need to be built underground or within craters, where natural shielding could help block solar radiation. Thick walls made from Mercury's own regolith soil might be used to construct habitats that maintain Earth-like conditions inside. Energy supply would be both an advantage and a challenge on Mercury. The planet receives 6 times more solar energy than Earth due to its closeness to the sun. Solar panels on Mercury would generate enormous amounts of energy, potentially powering entire colonies with ease. However, the high levels of heat and radiation would require special solar technology capable of withstanding intense conditions without degrading. Transportation and supply chains would also pose enormous hurdles. Sending humans to Mercury would require spacecraft capable of enduring extreme heat from the sun and precise navigation to avoid being pulled off course by the sun's powerful gravity. Unlike Mars or the Moon, Mercury's closeness to the sun makes it a far more dangerous destination for manned missions. To understand whether human life can exist on Mercury, we must first embrace the depth of its hostility. Unlike Earth, which is rich with protective systems and ecosystems that nourish life, Mercury is stripped bare of nearly everything humans require. Every critical factor, temperature, atmosphere, radiation, gravity, and resources, poses a barrier to survival. These challenges create a scenario where living on Mercury would be not only uncomfortable but potentially impossible without revolutionary advances in science and engineering. Radiation is one of Mercury's greatest threats. The planet has a weak magnetic field, only about 1% as strong as Earth's. Earth's strong magnetosphere deflects most solar wind and cosmic radiation, creating a relatively safe bubble in which life can flourish. Mercury's weak magnetosphere, however, cannot adequately shield its surface. With its thin exosphere unable to block radiation, the planet is constantly bombarded by high-energy particles from the sun. For humans, this would mean that prolonged exposure outside protective shelters would be fatal. Skin cancers, radiation sickness, and cellular damage would occur at accelerated rates. Radiation shielding would not be optional, it would be an absolute necessity. Mercury's soil, or regolith, is also problematic. The surface is covered in dust and rock fragments formed from billions of years of meteorite impacts. These materials may contain toxic elements, and exposure to Mercury's dust could cause respiratory and health problems, much like lunar dust is hazardous to astronauts. Thus, even building materials sourced from the planet would need careful handling and refinement to ensure human safety. To fully appreciate Mercury's challenges, it helps to compare it with other planets that humans have considered for colonization, such as Mars, Venus, and even the Moon. Mars has been the top candidate for colonization due to its similarities with Earth. It has a day length of about 24.6 hours, polar ice caps, seasons, and evidence of past water. Its atmosphere, though thin, still exists and offers partial protection. Compared to Mercury, Mars is far more forgiving. The cold temperatures and thin air are problems, but they pale in comparison to Mercury's boiling hot days and freezing nights. Venus, on the other hand, presents a different kind of hostility. Its thick atmosphere is composed mostly of carbon dioxide, with clouds of sulfuric acid and surface temperatures hot enough to melt lead. Yet, Some scientists have proposed that humans could live in floating cities high in Venus's atmosphere, where conditions are more stable. Mercury, by contrast, has no such atmosphere to exploit. The Moon is perhaps Mercury's closest cousin in terms of environmental hostility. Like Mercury, the Moon lacks an atmosphere, has extreme temperature fluctuations, and is constantly bombarded by radiation. However, its proximity to Earth makes it far easier to reach and supply. Mercury's distance and dangerous orbit near the Sun make it a far riskier target for colonization. In summary, while no other planetary body offers a true second Earth, Mercury ranks among the most difficult worlds for potential human habitation. It is less forgiving than Mars, less resourceful than Venus's atmosphere, and more distant than the Moon. This comparison paints a stark picture. If humans were to survive on Mercury, they would need technologies even more advanced than those envisioned for Mars or Venus missions. One of the most popular ideas in science fiction and futuristic planetary colonization is the creation of domed cities. On Mercury, this concept would be essential. Massive domes constructed from radiation-resistant materials could house entire human settlements. Inside these domes, artificial atmospheres could be maintained, complete with breathable oxygen, controlled temperatures, and protection from harmful radiation. Such domes could theoretically be built in Mercury's polar regions, near the water ice deposits. Access to ice would allow colonists to generate water, oxygen, and even rocket fuel, creating a self-sustaining cycle of resources. Solar power, collected from the abundant sunlight, would energize life support systems within the domes. However, challenges would remain. The domes would need to withstand Mercury's wild temperature swings, seismic activity from frequent meteorite impacts, and the constant threat of radiation. Cooling systems would be required to prevent overheating during the long Mercurian day, while heating systems would protect against freezing nights. Designing such structures is not beyond imagination, but it would require materials and engineering far beyond our current capabilities. Another potential solution for colonizing Mercury lies beneath its surface. By building habitats underground or within natural caves, humans could shield themselves from radiation, temperature extremes, and meteorite impacts. Thick layers of rock and regolith would serve as natural barriers against cosmic rays and solar particles. Underground habitats could be equipped with artificial lighting, hydroponic farms, and oxygen generation systems. With Mercury's weak gravity, transporting heavy equipment and digging tunnels would be easier than on Earth. Colonies could be powered by solar energy collected on the surface and transmitted below. This concept of subsurface living is not unique to Mercury. Similar ideas have been proposed for colonizing the Moon and Mars, where radiation exposure poses a serious threat. The difference is that on Mercury, underground living might not just be practical, but essential for survival. Looking further into the future, some scientists and futurists speculate about creating artificial atmospheres or magnetic shields for hostile planets. While this is purely theoretical today, it remains an intriguing possibility. Imagine deploying massive satellites or space-based structures around Mercury that generate a protective magnetic field, deflecting harmful radiation and solar wind. Such technology could mimic Earth's natural magnetosphere, creating safer conditions for colonization. Similarly, domed cities might eventually be replaced with entire regions covered by artificially generated atmospheres, maintained by advanced machinery that replenishes gases and controls climate. These ideas remain speculative, but they represent humanity's potential to not only adapt to hostile environments, but reshape them entirely. In this vision of the future, even Mercury, with all its dangers, could be transformed into a habitable world for humans. Another approach to living near Mercury might not involve the planet's surface at all. Instead, humans could build orbital colonies around Mercury. These massive space stations could take advantage of Mercury's proximity to the Sun for abundant solar power while avoiding the dangers of its surface. Colonies in orbit could serve as research hubs, mining stations for resources, or stepping stones for missions deeper into the solar system. The concept of orbital colonies is often linked to Gerard K. O'Neill's vision of space habitats, gigantic rotating cylinders in space that generate artificial gravity through centrifugal force. Such habitats could orbit Mercury while drawing energy from its sunlight and raw materials from its surface. This would allow humans to exploit Mercury's resources without facing the extremes of its ground environment. Even if humanity were to develop advanced technologies that allowed survival within domes, underground habitats, or orbital colonies near Mercury, the human body itself would remain a critical limiting factor. Earth's environment has shaped human biology over millions of years. When removed from this delicate balance, the body undergoes stress that can be dangerous if not carefully managed. One of the greatest concerns is the effect of low gravity. Mercury's gravity is about 38% of Earth's, similar to Mars. While this makes heavy lifting easier and reduces the strain of movement, long-term exposure to reduced gravity can have harmful consequences. Muscles weaken due to reduced resistance, bones lose density, and the cardiovascular system struggles to maintain efficiency. Prolonged stays on Mercury could result in fragile skeletons, weakened immune systems, and overall frailty. To combat this, colonists would require strict exercise regimens, possibly involving resistance machines or even centrifuge-based artificial gravity systems within habitats. Another biological challenge is radiation exposure. Even within shielded habitats, some radiation would inevitably penetrate. Over decades, this could increase the risk of cancer, DNA damage, and fertility issues. Future medical technologies, such as advanced gene therapy, radiation-resistant drugs, or even genetic modifications, might be required to help the human body cope with Mercury's dangerous radiation environment. Furthermore, the absence of natural ecosystems poses a psychological and biological burden. On Earth, humans rely not just on technology but on the balance of nature. Plants produce oxygen, microorganisms recycle nutrients, and a diverse biosphere supports physical and mental health. On Mercury, everything would have to be artificially created. Colonists would need closed-loop life support systems capable of recycling air, water, and waste with near-perfect efficiency. Hydroponic or aeroponic farms would be necessary to grow food in controlled environments. This dependence on technology creates a fragile existence. Any failure in the system could spell disaster. Beyond the physical barriers, the psychological effects of living on Mercury could be even more daunting. Humans are not only biological beings but also social and emotional ones. The harshness of Mercury's environment, combined with isolation from Earth, could create profound mental challenges. First, the long days and nights on Mercury would disrupt human circadian rhythms. A Mercurian day lasts 176 Earth days, meaning colonists would experience months of daylight followed by months of darkness. Such unnatural cycles would wreak havoc on sleep patterns, hormonal balance, and mental health. To overcome this, habitats would need artificial lighting systems that simulate Earth's 24-hour cycle, helping maintain a sense of normalcy. Second, isolation and confinement would test human psychology. Colonists on Mercury would live in small, enclosed habitats, with no possibility of stepping outside unprotected. Unlike Earth, where a simple walk in nature can relieve stress, Mercury offers no such escape. Over time, feelings of claustrophobia, depression, and anxiety could intensify. Psychological support, social cohesion, and perhaps even virtual reality technologies would be critical in maintaining mental health. Third, the distance from Earth would strain human relationships and communication. While Mercury is not as distant as outer planets, the psychological effect of being millions of kilometers away from home, in a place so hostile to life, would weigh heavily on colonists. Video calls and messages might ease this, but the sense of disconnection could still be profound. The human spirit thrives on exploration and challenge, but it also requires comfort, familiarity, and community. Balancing these needs on Mercury would be one of the greatest psychological experiments in human history. The idea of colonizing Mercury, or any planet, raises important ethical and philosophical questions. Should humanity attempt to inhabit such hostile worlds? What responsibilities do we carry when altering another planet's environment for our survival? One ethical concern is resource allocation. Colonizing Mercury would require trillions of dollars, decades of effort, and immense scientific resources. Critics might argue that these resources would be better spent addressing urgent problems on Earth, such as climate change, poverty, and environmental destruction. Should we invest in saving our own planet before attempting to survive on another? Another question involves planetary protection. While Mercury is barren and unlikely to host life, other planets or moons may not be so sterile. Humanity must consider the moral implications of contaminating other worlds with Earth life. Colonizing Mercury might set a precedent for how we treat celestial bodies, not as pristine natural objects, but as resources to be exploited. There is also a philosophical question of purpose. Why colonize Mercury at all? Unlike Mars, which could one day serve as a backup Earth, Mercury offers little in terms of habitability. Some might argue that colonizing Mercury would be less about survival and more about the challenge itself, a demonstration of human resilience and ingenuity. Others might view it as a stepping stone toward expanding human presence across the solar system, making use of Mercury's resources and strategic location near the Sun. Despite its extreme challenges, Mercury does offer potential benefits that could make colonization worthwhile. First, Mercury's proximity to the Sun provides unparalleled access to solar energy. With 6 times the solar intensity Earth receives, colonies on Mercury could generate enormous amounts of renewable power. This energy could be harnessed not only for survival but also for powering large-scale space industry. Solar farms on Mercury could supply energy for spacecraft, orbital colonies, or even beamed back to Earth through microwave or laser transmission. Second, Mercury's raw materials make it a potential hub for mining. The planet is rich in metals such as iron, nickel, and silicate minerals. Colonies could mine these materials for use in space construction, reducing the need to launch heavy resources from Earth's gravity well. Mercury's position in the solar system could make it a vital resource hub for future interplanetary industry. Third, Mercury's scientific value is immense. Colonizing Mercury would give humanity unprecedented access to study the Sun and its effects on a nearby planet. Observing solar radiation, magnetic storms, and planetary geology up close would revolutionize our understanding of both astrophysics and planetary science. Mercury could serve as a laboratory for studying how planets form and evolve, offering clues about the origins of our own world. Finally, colonizing Mercury could serve a strategic purpose. As humanity expands across the solar system, having a presence on Mercury could provide unique advantages. Its location near the Sun makes it an ideal place for monitoring solar activity, protecting colonies elsewhere. Its resources and energy could supply missions heading further into the outer solar system. In this sense, Mercury might not be a home in the traditional sense, but a base of operations in humanity's cosmic journey. When considering all the evidence, the verdict seems clear. Mercury is one of the most hostile planets for human life. Its searing heat, freezing cold, lack of atmosphere, intense radiation, and barren surface create a world far removed from the needs of human biology. Without revolutionary technological advances, human life cannot naturally exist on Mercury. Yet, the story does not end here. Humanity has always thrived by conquering the impossible. Just as early explorers braved the open oceans and astronauts braved the vacuum of space, one day humanity might conquer Mercury's hostility. With domed cities, underground habitats, artificial atmospheres, and powerful solar technologies, humans might carve out a fragile existence on this extreme planet. Whether this will ever happen remains uncertain. But the question itself pushes us to expand the boundaries of science, imagination, and human potential. A broader reflection on what Mercury teaches us about human survival in the universe. If we were to fast forward centuries into the future, we might find humanity having conquered the impossible and established colonies on Mercury. What would daily life look like in such an environment? The picture is both extraordinary and alien to our present-day experiences. Imagine waking up inside a vast domed habitat located near Mercury's North Pole, close to the precious deposits of water ice. Outside, the landscape is barren and silent, painted in shades of gray and brown, illuminated by a sun that looms 3 times larger in the sky than it does on Earth. But inside the dome, the atmosphere is Earth-like, breathable air, regulated temperature, and artificial daylight that follows a carefully engineered 24-hour cycle. This artificial environment would mimic Earth's conditions, ensuring that colonists maintain healthy biological rhythms. Food would not come from outdoor farms, for Mercury's surface cannot sustain crops. Instead, colonists would depend on hydroponic and aeroponic farms located within underground chambers. Rows of plants, wheat, potatoes, fruits, and even genetically engineered crops designed to withstand limited sunlight would grow under LED lights powered by Mercury's abundant solar energy. Nutrient solutions would replace soil, and water recycled from melted ice and waste streams would feed the closed ecosystem. Farmers in Mercury colonies would spend their days monitoring growth systems, repairing pumps, and ensuring that food supplies remained constant and reliable. Energy would be the least of Mercury's problems. With the sun's relentless rays, solar power stations would flourish across the planet's surface. Vast arrays of heat-resistant solar panels could provide more energy than the colony could ever use. Some of this energy might even be transmitted back to Earth or to other colonies across the solar system through wireless power beams. In this sense, Mercury could become humanity's solar powerhouse, fueling civilization's expansion beyond Earth. Daily routines would differ from life on Earth. Colonists would live within controlled environments where every resource, air, water, and food, was recycled. Waste would not exist as we know it. Instead, advanced recycling systems would transform all byproducts into usable forms. Even human waste would become part of the cycle, feeding plants or fueling energy systems. Nothing would be wasted, for survival would demand efficiency. Movement outside the habitats would be rare and highly regulated. Venturing onto Mercury's surface would require specialized exosuits capable of withstanding extreme temperatures and shielding wearers from radiation. Such expeditions would mostly involve mining operations, scientific exploration, or maintenance of solar farms. For safety, these excursions would be scheduled during transitional times between Mercury's long days and nights, when conditions were less extreme. Children born in such colonies would know nothing of Earth's blue skies, oceans, or forests. For them, Mercury's domes and underground cities would be normal. Education would not only include traditional subjects but also focus on space survival, engineering, and science. Playgrounds might consist of artificial gravity chambers or virtual reality simulations that allowed children to experience Earth-like environments. Virtual reality would likely be essential for mental health, allowing colonists to escape the monotony of confined habitats and explore simulated beaches, forests, or even games of flight across Mercury's alien landscapes. Human survival on Mercury would be impossible without the assistance of advanced artificial intelligence, AI, and robotics. These technologies would serve as humanity's partners, performing tasks too dangerous, tedious, or complex for humans. AI systems would manage life support systems with flawless precision. They would regulate oxygen levels, water recycling, and temperature control, ensuring that even the smallest fluctuation is corrected before it becomes a threat. AI would also monitor radiation exposure and structural integrity, alerting humans to potential hazards long before they become critical. Robotics would dominate surface operations. Mining robots, resistant to Mercury's heat and radiation, would extract valuable metals and transport them to processing plants. Maintenance drones would patrol solar farms, cleaning dust off panels and repairing damaged systems. These robots would be designed to withstand conditions that no human could endure for long. Medical AI would also play a crucial role in Mercury colonies. In such isolated environments, access to Earth's hospitals would be impossible. Instead, AI-driven diagnostic tools, robotic surgeons, and automated pharmacies would ensure that colonists receive immediate medical attention. Genetic therapies and nanotechnology might even be administered routinely to combat the harmful effects of radiation or low gravity. The partnership between humans and machines would not be optional, it would be essential. Mercury colonies would function like a symphony of biological and mechanical systems, each supporting the other in the fight for survival. Colonizing Mercury would not simply be about survival, it would also carry symbolic weight for humanity. By conquering such an extreme world, humanity would prove that its resilience is boundless. Mercury, once thought to be utterly inhospitable, would stand as a testament to human determination, creativity, and unity. It would also symbolize a shift in humanity's relationship with the cosmos. Instead of seeing planets as distant, unreachable worlds, we would begin to see them as canvases upon which human ingenuity could write new chapters of civilization. Colonizing Mercury would remind us that no frontier is truly impossible when science, technology, and willpower unite. Even if humanity never truly colonizes Mercury, the study of whether life could exist there teaches us invaluable lessons. Mercury represents the extreme limits of habitability, a world that challenges every assumption about what humans need to survive. By studying its environment, scientists gain insights into how planets evolve, how life depends on delicate balances, and how fragile our existence truly is. The exercise of imagining life on Mercury also highlights the importance of Earth's uniqueness. Our planet is a rare oasis in a universe filled with barren, hostile worlds. The air we breathe, the water we drink, the ecosystems that surround us, these are luxuries that Mercury cannot offer. In this way, Mercury reminds us of the urgency to protect our own world, even as we dream of reaching others. Finally, Mercury demonstrates the importance of adaptability. Human life, as it currently exists, cannot survive on Mercury. But through imagination, technology, and evolution, we can envision ways to thrive even in the most hostile environments. This adaptability is the very essence of what makes us human, the ability to go beyond limitations, to dream of the impossible, and to transform dreams into reality. Tie together the scientific, philosophical, and symbolic lessons into a powerful ending that resonates. When we ask whether human life can exist on Mercury, the straightforward scientific answer is no. The planet's extreme environment, its searing daytime heat, freezing nighttime cold, lack of atmosphere, and unrelenting radiation, makes it one of the most inhospitable places in the solar system. Without the shield of air, the comfort of stable temperatures, or the protection of a strong magnetic field, Mercury stands as a barren rock, forever hostile to the biology of Earth. Left to nature alone, human beings could never survive on its surface. Yet, humanity has never been content with the boundaries nature imposes. Every great leap in history, from fire to agriculture, from sailing across oceans to reaching the moon, was achieved by facing the impossible and daring to reshape the environment. Mercury, in this sense, is not merely a planet. It is a challenge, a test of how far we are willing to push our imagination and technology to ensure survival beyond Earth. Realistically, Mercury is unlikely to become humanity's second Earth. Mars, with its more forgiving climate and potential for terraforming, stands as a more practical candidate for long-term colonization. Venus, with its thick atmosphere, offers the possibility of floating cities. The Moon provides a nearby stepping stone for testing life support systems. Mercury, by contrast, is better suited as a scientific outpost or industrial hub rather than a home. Its proximity to the sun makes it ideal for solar energy harvesting, while its mineral-rich crust could support large-scale mining operations. Colonies on Mercury might never number in the millions, but small, highly specialized communities could thrive, scientists studying the sun, engineers operating solar farms, and miners extracting resources to fuel the expansion of humanity across the solar system. In this vision, Mercury becomes humanity's frontier laboratory, a place where technology is tested against the harshest of environments and where lessons are learned that can be applied elsewhere. Living on Mercury may never be comfortable, but it could be purposeful. Beyond practicality, Mercury carries profound philosophical significance. It forces us to confront the fragility of life and the uniqueness of Earth. Standing on Mercury, gazing at the vast, unforgiving sun, one would be reminded that life on Earth is not the universal norm but a rare exception. Our planet's breathable air, flowing water, and thriving ecosystems are gifts that no other known world can replicate. At the same time, Mercury symbolizes the indomitable human spirit. The very act of considering life on such a hostile planet reflects humanity's refusal to accept limits. Even if Mercury is never truly colonized, the effort to imagine and prepare for such a possibility pushes the boundaries of science, engineering, and philosophy. It teaches us that survival is not just about adapting to comfort, but about transforming the impossible into the achievable. Looking to the distant future, Mercury may not be humanity's home, but it could play a critical role in our journey to the stars. As a base of energy and resources, it could power spacecraft that travel deeper into the solar system. As a platform for solar observation, it could protect other colonies from solar storms. As a proving ground, it could prepare us for even more extreme worlds beyond our sun. In this way, Mercury becomes part of humanity's cosmic stepping stones. Each world we reach, whether the Moon, Mars, or Mercury, teaches us how to survive, adapt, and thrive. Each challenge conquered brings us closer to becoming a multiplanetary species, no longer bound to one fragile world. So, can human life exist on Mercury? Not naturally, not easily, and perhaps not permanently. But with vision, determination, and technology, human life could one day carve out an existence there, not as a thriving civilization, but as a testament to human endurance. Mercury will never be Earth. It will never offer oceans, forests, or open skies. But it may serve as one of the most powerful reminders of what it means to be human, to face impossibility, to adapt, and to turn barren wastelands into frontiers of progress. In the end, Mercury is not the world we will call home. It is the world that will remind us why Earth is worth protecting, why the stars are worth reaching, and why humanity's destiny lies not in comfort, but in courage.